All right, here we're looking at our notes for section 6.4, and we're going to be working through our notebooks again. So we always want to start with our learning targets. And so for today, our learning targets are I can use and identify exponential growth and decay, and then I can solve equations using compound interest. So you're going to need two different pieces to go in your notes. Today they look sort of like this. So take a minute and cut along all of these lines. Don't cut all the way through to the very top, because this is the part that we're going to be gluing, so then you can flip up your little folds and see what the parts of these equations look like and how to use them. And the first one we're really going to be looking at is our exponential growth and decay. So that's the first one you're going to need. And you definitely will need your notebook, because we're going to write some things on the page below, right below it. The other thing you absolutely need today is some colors, because we do this on purpose sometimes, and today is one of those days. So our exponential growth and decay equation, we have y equals, and here's where your colors come into play. Each one needs to be a different color. A, and we'll talk about what they mean in just a minute, times 1 plus or minus r to the t. And remember, this has to be an exponent, so make sure it actually looks like an exponent in your writing. Okay, so I've got y equals a times the 1 plus or minus r to the t. So now let's see what these things all mean. So this is what we're dealing with, exponential growth and decay. We're going to see this equation used a lot when we're talking about population growth, because people and animals and creatures and bacteria tend to grow exponentially. We also look at decay for that same rate. So populations can also decay exponentially. So we're actually going to use this quite a bit. So how I like to think about an exponential growth kind of just scenario is if I was to tell someone, I was to tell 3 people a secret, and then they would all tell 3 people, and then each of those people would tell 3 people, and then each of those people would tell 3 people. That's kind of what an exponential growth would look like. So now let's go ahead and label what each piece means. So this y value, this is our final amount. So you're going to go ahead and fold this up and make sure you go ahead and glue this down. That y is our final amount. Okay, that's what we end up with. Equals, we kind of know what equals means. This a, this is kind of our next important one that we're really going to be looking at. And this is our initial amount. Okay, kind of what we start with. 1 plus or minus r, we're just going to look at this r right now. This is my rate. The big thing here is this has to be in decimal. Often you'll be given this rate as a percentage, and you have to turn it into a decimal first before you can actually do anything. And then t, of course, is our time. Okay, so this is our time. And usually our time is in years, but not always, so it will depend on the equation. Okay, so the other important thing that we need to know is now that we have our equation and what each piece means, I've got my final value, I've got my initial value, I've got my rate, and I've got my time. This chunk right here in my parentheses, that's what we're writing down here. This is called my growth or decay factor. And how I know which one it is if it's greater than 1, then it's growth. And if it's less than 1, it is decay. Okay, so if the entire thing in my parentheses is greater than 1, then I know I'm adding a rate, so it's getting bigger. But if this whole thing inside my parentheses is less than 1, then I know I've subtracted a rate, which means it's getting smaller and smaller, which means it's decay. Okay? So one way I can think about that is I'm going to show you an example from my other notebook, right here, is how we can determine if it's growth or decay. So here we again start with our table, and I see I've got my x values increasing by 1. Here I see I'm dividing by the same thing. So I'm getting smaller and smaller by the same thing. So since I'm dividing, I know that this is going to be decay. For this example, again, my x values are increasing by 1 each time, but I'm multiplying by the same thing. I'm doubling. So that's getting bigger. So this is going to be an example of exponential growth. Okay? So we're going to use this a lot for just growth, decay. Whenever you see those kind of words, this is the equation you're going to be using. So go ahead and take a second and glue this in and make sure that it is exactly where you need it to be. So the next formula we're really going to be looking at in this section is our compound interest. Okay? So we've looked at simple interest, but now we're looking at compound interest. The biggest thing here is, I'm going to just label my page, is you have to see the word compound. Oftentimes people try and use this equation when they just see interest, but you must see the word compound. So I highlighted that to make it kind of really important. I'm going to go ahead and glue this top piece down so that I know that I can add in the things that I need to add. Okay, so we're dealing with our compound interest here. Okay, so here's our different variables, and again we're going to use colors here. So y, and this y again is the final balance. Okay, so I'm going to flip this up and I'm going to kind of write as we go. So this y is my final balance. And we're going to say balance and not just amount, because when we're dealing with compound interest, we're always dealing with money. So it is going to be an amount of money. This is a P, and this is a capital P, okay? Because there's a difference. This is the principal. That's what this is called. This is the principal. And that's the starting amount. That's how much you start with in the account. Okay? So then here's where we're going to use kind of this little piece right here, and you're going to need two colors. This is R divided by N, and I'm using some very different colors. And then this is my other N, and here's my exponent to the T. These two things in my exponent are multiplied together. Okay? So underneath these two flaps, right, because this N is in both places, we're going to use that as well. So that N is the number of times per year it is compounded. See, and I've written that underneath both of them. So then R is my rate, again in decimal form. So again, if you get a percentage, go ahead and turn it to a decimal first. So remember, the N is the number of times per year that it's compounded. And here my T, of course, is my time, and this one is in years. Okay, so that's kind of our important piece, is that time is in years. So now we're going to look at an example, and I would love for you to actually kind of write this one down as we go. So I'm going to use just a normal pen and write this, and then we're going to highlight things in certain colors. Okay, so you deposit $100 in a savings account. That earns 6% annual interest, compounded. Here's that magical word. So we know that we can use this equation monthly. What is the balance after T years? Okay, you're going to have these kind of examples a lot, and so I want to walk through one with you. Okay, so first of all, let's take our colors that we've been using and mark up our equation of what we're dealing with. So I know I deposit $100 in an account. Well, that's my starting amount, so that's going to be my principal. So that's going to be green. In a savings account that earns 6%. Oh, that's a percentage or a rate, so that's going to be my rate. Annual interest compounded. Oh, this tells me how often it's compounded. So what is the balance? That's that final amount that I care about after T years. So now that I've got everything kind of colored, I can go ahead and write my equation. So I'm going to have y equals that principal, that green one was 100 times 1 plus, right? And it's earning interest, so it's this plus. That rate was given to me as a percentage. And I know that to convert from a percent, I take my percent symbol and I move it 2 places to the left, and that's my decimal. Okay, so I know that that becomes my decimal, so 0.06. This is compounded monthly, and remember that our N is the number of times per year. So if it's compounded monthly, there are 12 months in a year. So it's going to be a 12. And then here I also have that 12. It doesn't go away. We'll use it again. And then my t. We're not given the t here. So where this equation can come in really handy is sometimes you'll be saying, okay, so now that you have your equation, so how much money will you have in 4 years? Okay, so now how about 5 years? How about 7? So now that we have our equation, we can just plug in those different t values and see where we end up. Okay, so now you have both of our equations that we're really going to be using in this section. So make sure you understand kind of the difference between the two of them and when you can use them. You may only use this one if you ever see the word compound interest, or it's compounded monthly, as in our example here. Okay, we'll be using the other one a lot too for just any exponential growth or decay. So now that we've gone through these and you have your examples, make sure you keep them with you and so you can plug in the pieces that you need. Go ahead and work on that homework, and as always, ask me and come find me whenever you get stuck or have questions.